What is science anyway? And while we're at it, what isn't science? It's me, Moser. And after this video, you should be able to distinguish science from other ways of understanding the world, recognize that science is both consistent and tentative, and describe qualities that are shared by all scientific ideas. Science. Love it or hate it, a lot of people have a lot of, well, just frankly incorrect notions about what science is. It's not a body of facts. It's not a set of experts. It's a way of thinking, and it actually happens to be an incredibly powerful tool to understand the world. That's fantastic. So when we look at an idea or a concept and we attempt to decide if it's scientific, we ask ourselves some pretty simple questions. Because all scientific ideas have some things in common. Science, no matter where or when it's done, shares a set of core characteristics. So, what is science? Well, science is consistent. Consistent? Well, it's changing all the time. What do you mean consistent? It's not consistent. We mean internally consistent. So, the rules of science, the laws of the universe, function the same way in all places and in all times, which means that if you conduct an experiment in Northeast Ohio and someone conducts the same experiment in South America or Europe or Antarctica, it should be, the substances involved should behave in similar ways because the rules don't change from location to location. It means that the laws of physics on a planet somewhere out here in this galaxy are going to work the same way that they are out here. Scientific ideas, when we have a new idea in science, we look to see if it's consistent with the existing body of knowledge. Not that new things don't happen, but generally, things are relatively consistent. Consistent and yet tentative? Really? Well, yeah. And this is actually one of the criticisms that people who don't understand science level at science. Well, it's changing all the time. One day they say this is true, and then the next day they change their minds. They're not changing their minds. Science responds to new information. And when faced with new information, sometimes your conclusions have to change. One of the things that people love to criticize as an example of this sort of fickleness of science is food guidance. So this is actually a food choices chart published by the United States Department of Agriculture in the 1940s. It's got groups of food that we don't even recognize. We don't split our green and yellow vegetables. That's okay. Things change. By the 1960s, the Daily Food Guide had been simplified into 4 groups rather than 7. By the 70s, it was back up to 5 groups as they added fats and alcohols. By the 80s, we had the food wheel pattern for daily food choices, fruits, vegetables, meats. We had fats, sweets, alcohol, cheese, dairy. Breads and grains were now a group. And in the 90s, the food pyramid was born, and we had yet another arrangement, mostly of the same information, but the guidance on how much of what to eat had changed. Shortly after the year 2000, we had yet another one that increased the amount of some foods that were recommended and decreased the amount of other foods that were recommended. Until today, we have this, which is even more simplified. But yeah, have recommendations changed? Yes, because food science has changed, because our understanding of how the body works with nutrition has changed, because science, it's tentative. When we think about something in science, something that science is going to be able to help us understand, it has to be observable. So we could look through a microscope at bacteria, but can we see the molecules in that test tube? Can we see the behavior of atoms? No. Science can understand things that aren't directly observable by observing evidence of those things, processes, or their behavior. This neat little chart here is called an NMR, and it's a readout that you get by bouncing waves off of chemicals. And those spikes indicate the reflection of certain kinds of molecules. You can figure out what molecules are in that test tube without ever observing directly the chemicals in it, but by observing evidence of their presence through the behavior of a magnetic wave. Whoa, that's pretty cool. Well, what about this? The Earth has layers. Geologic processes have been going on for 4.6 billion years, but we don't have evidence of those processes in early Earth. We haven't even actually directly observed the center of the Earth. How do we know it's there? Well, again, we can observe evidence of processes or structures without directly observing them. Note that all these things are natural. And when we say that science is concerned with the natural, we don't mean like organic carrots here. We mean things that are of the natural world. So science can't take an opinion on, is there a God, or are there ghosts? Because those ideas are outside the natural. They're moving on a different set of rules. The only things that science can weigh in on are things that are, part of the natural world. One of the wonders of science is the ability of scientists to use scientific ideas to predict. And I don't mean a crystal ball. I mean things like the weather. That's pretty powerful, but that's science for you because we have an understanding of the behavior of gases in the atmosphere that allows us to predict weather patterns far better than we ever have in the past. And scientific ideas have to be able to be tested. So we can predict weather patterns and then we can watch and see if those predictions are correct. That's one way to test an idea. We can also do larger scale things like model systems or processes and then try to backfit existing data to those models to see if they work. We're testing the predictions that are made with scientific ideas. Science is consistent, tentative, observable, predictable, natural, and above all, testable. And the community of scientists around the globe take ideas, discuss them, test them, try them out, and together work towards a better understanding of the world and the universe that we live in. So, that's science in a nutshell.